the thing that makes factoring these quadratic equations so difficult is all about this a value, that coefficient on the x squared term. So whenever that has multiple factor pairs as well as the c term having multiple factor pairs, especially when it's negative, because then you've got multiple combinations of each factor pair where one or the other factor is negative, you end up with so many possibilities, it's really, really tough to figure out how to factor this into this form, where you have two binomials. So think about this. First of all, so 6 could be, this could be a 6x and it could be a 1x. We know that this is going to be a plus and a minus, although we don't know which one the plus and minus goes with. And then these numbers that have a product that becomes the c value also has a bunch of factor pairs. So for 20, you've got 1 and 20, 2 and 10, 4 and 5. And remember, since it's negative, it could be a negative 4 times positive 5 or positive 4 times negative 5 and so on for all of those factor pairs. And the other thing that makes it tough is, so you're looking for a factor pair of 20, but it's not a factor pair of 20 that adds up to 7. It adds up to 7 when the factor pair of 20 is multiplied by a factor pair of 6. So all of a sudden, the number of possibilities is huge. And you can solve these just by doing some tinkering and trying a bunch of different versions of it. And sometimes you get lucky and you just stumble upon it. Other times it feels like you try every possibility and none of them seem to work, which in fact is also a possibility. If you have an unfactorable quadratic equation, that means it might actually not have x-intercepts. Because for it to have x-intercepts, it has to be factorable into two binomials. So that would be a parabola that sits above the x-axis and never crosses it. This one, however, does have x-intercepts, so I wouldn't pick one that wasn't factorable to show you how to factor these more complex ones. So like I said, you can tinker with them and guess and check until you get something that works, but that can take a really long time. So I was going to talk about some of the strategies for honing in on the correct numbers to factor this into. So one of those strategies is actually called a box model. And you might remember using something like this for doing multi-digit multiplication. So if you were doing like 25 times 17, that's two two-digit numbers. And if you remember, you could multiply them this way. So if you're doing 25 times 17, you could do 25, 10, and 7. You split it into the 10s and the 1s, basically your two different terms. And then each of these becomes one of the pieces of the product. You add them all together, and at the end, you have it. So maybe you remember doing something like this. Now, it turns out you can do the same thing, and this is a strategy for multiplying binomials, but it's also a tool that helps you factor binomials. So in order to understand how you can use this for factoring, I have to show how you would use it for multiplying binomials, and you'll see there are some relationships amongst the values and the terms that go in each of the four boxes that actually help you zero in on what the four terms are in your two binomials when you factor this equation. So I'm going to actually start with a real simple distributing problem that doesn't have too many possibilities, just for the sake of making this a little bit clear. So imagine you had 2x plus 1 times x plus 3. So we know we could use FOIL, and we end up with 2x squared. And that would be plus 7x, because you've got, I'll write this, plus 6x plus 1x plus 3. So that's using the FOIL method. I was using that strategy in my head. You could also use your box model to do this. So you would have 2x and your plus 1, and you would have your x and your plus 3. And notice those four terms end up in your four boxes. You're doing 2x times x goes in this box, x times 1 goes in this box, 2x times 3 goes in this box, and 1 times 3 goes in that box. So if you add those all together, 2x squared plus x plus 6x plus 3, and simplify it, you have your standard form equivalent expression. So notice there's a couple things about this, though, that actually helps us with factoring. There's two things. One of them is Notice these two, we always put the ax squared term in the upper left. We always put the c term in the bottom right. These two that are diagonal from each other, those are your two x terms that combine to make that bx term in the final equation. Those are the two pieces that add together into that. So notice those two add up to 7x. Those are always going to add up to your bx term. But another thing to notice, and I can't really explain why this is, and I'm not going to do it now. So notice they're called cross products. Notice the product of these two, that would be 6x squared, is equal to the product of those two. It's almost kind of like when you write a proportion, like 1/4 equals 5/20. If you write that at proportion, cross products are equal to each other. The same thing happens here. Both of those products are equal to 6x squared. So those relationships are really important when we use this for factoring. So again, you don't really need this for distributing unless you like using this if you learn multiplication that way, but it's for factoring that we're going to really use this. So let's look at how we can use this to factor this more complicated 6x squared plus 7x plus 20. So to do this, set up your box. Now we don't know what these are, but you know you're going to have something times x here plus something. You know you're going to have something times x here and minus something. That the plus and the minus, I know that it has to be a positive and a negative because remember we have that negative 20. So we know that in our factor form equation, the two last values have to be a positive and a negative to have a negative product. And we know a couple pieces that go into this box model. We know the 6x squared is going to go here, and we know the negative 20 is going to go here. And so it's just the two pieces that contribute to that bx term that we don't know. So we don't know what these two are, but we do know that they have to add up to 7x. That's one part of it. We know they add up to 7x. The other piece that's going to help us is that idea of cross products. So we know that whatever this product is, 6x times negative 20, that is negative 120. I'm not going to worry about the x squared piece on there because it's really just the values we're trying to pick up. We know that each of these terms over here is going to be something times x and something times x. We know that part. We just don't know the coefficients that go with those two terms. So what we know, though, is those two terms, they have to have a product of 120, the two coefficients of negative 120. So one's positive and one's negative. And we also know they have to add up to 7x. So now we're actually back to that same idea we use when we're factoring the simpler quadratic standard form equations, where you're looking for a number that has a product of c and a sum of b in ax squared plus bx plus c. So we know we're looking for a product of negative 120 that adds up to 7. Okay, so what we do is we start listing off the factor pairs of 120. I'm not going to worry about the signs right now. I'm just looking for two that if one of them was negative and the other was positive, they would add up to 7. That actually tells you that the two factors can't be that far apart. So like 1 times 120, that's a factor pair of 120. There's no way that's going to be, with one of them negative, it's never going to add up to 7. And then this one has a ton of factors, so you can just work your way down. You'll notice the numbers get closer to each other. 60, 3 times 40, 4 times 30, 5 times 24. So notice we're getting closer. 5 and 24 are getting closer to each other. But even if 5 was negative 5 plus 24, we're still not at 7. So we keep on going. 6 times 20, getting close. So if that 6 was negative, negative 6 plus 14, ooh, that was getting really close. That would be 8. So the next one, 8 times 15, that's got to be it. Notice if it was negative 8 times 15, it would have a product of negative 120. And if you do negative 8 plus 15, we get 7. So what I'm going to do is, and it actually doesn't matter which blank you put the negative 8 and the 15 in, negative 8 and 15, this would work the same if we did it the other way. If we put the -8 in the bottom left and the 15 in the top right, we would end up with the same two binomials when we do this next step. Anyways, so the next step is, so we've got the four pieces that we would get if we were using FOIL with the factored form equation. If we had two binomials and we used FOIL, we know that these would be the four terms we would get from whatever those are. And remember, we're multiplying those to get each of those. When you're doing FOIL, each of them is a multiplying step. So what we're actually going to do is we're going to pull out the greatest common factor of each row and column in order to get what the four terms are that make up our two binomials. So first of all, let's start with the left column. The left column, we're looking for the greatest common factor of 6x squared and 15x. So 6 and 15, their greatest common factor is 3. They also both have at least one x, an x squared and an x. So the greatest common factor is 3 times x. If we do the next column, so now we're looking at the greatest common factor of -8 and -20. And when they're both negative, you're factoring out a negative term. If one's negative and one's positive, you factor out the positive term. We would spend a lot more time on this if it was a normal school year. I'm going through this kind of quick. So greatest common factor of -8 and -20 is -4. So one of our expressions is 3x minus 4. So now we're factoring both rows. So the greatest common factor between 6x squared and -8x is 2x. And the greatest common factor of -20 and 15 is 5. And remember, one had to be negative, one has to be positive. This is the positive one. And if you forget that part and you have the signs the wrong way and it doesn't quite work, you can always just switch the signs later. Sometimes there's some fine tuning if you make a slip at one of those steps. So we have a factored form equation now of 3x minus 4 times 2x plus 5. And you can always double check it by doing FOIL and making sure that you end up with the original 6x squared plus 7x minus 20. So after this point, you're in the same spot as any other complicated or more simple version of the equation. Now you can use those two expressions to calculate the two x-intercepts, find the midpoint between them to find the x value of the vertex, use that to find the y value of the vertex, and we know we have a vertically stretched upward opening parabola with a y-intercept at -20. Whew,